Hello everyone. Today I'm excited to present our work, a unified framework for high frame rate, high dynamic range video synthesis. Videos with high dynamic range and high frame rate are essential for capturing realistic scenes. They preserve fine details and smooth motion, which are important for applications like filmmaking, autonomous driving, and surveillance. However, achieving both at the same time is very challenging. Cameras have a limited dynamic range, making it hard to preserve both bright highlights and dark shadows. Increasing the frame rate often means shorter exposures, which can introduce noise and loss of detail. While specialized sensors can capture high frame rate HDR video, they are expensive and impractical for most systems. Our work takes a low-cost software-based approach using alternating exposures captured by standard cameras. Existing methods usually handle HDR reconstruction and frame interpolation separately. This two-stage process increases computation and ignores the relationship between exposure and motion. It's also limited by the lack of large-scale, real-world training data. To overcome these issues, we propose a unified framework that performs both tasks jointly. Our key idea is to extend an HDR reconstruction network with a lightweight flow interpolation module based on a quadratic motion model, which helps handle real-world motion more accurately. When ground truth HDR data is available, we train the model supervised, using a reconstruction loss in the tone map domain. But since collecting large HDR video datasets is difficult, we also design a self-supervised training framework inspired by classical exposure fusion. Directly applying exposure fusion isn't possible in the case of most videos which only have one exposure per frame. Instead, we incorporate this constraint through a weighted photometric loss, which downweights unreliable regions such as dark shadows or clipped highlights. We also add a cycle consistency loss to ensure the synthesized frames stay temporally coherent. To support this work, we built a new high frame rate HDR dataset with real-world videos across diverse lighting and motion conditions. Experiments show that our model achieves comparable or better quality than state-of-the-art methods while running at about 2.5 times faster. Qualitatively, our method produces sharper images and better preserves details, especially in fast motion or high contrast scenes. Even in the self-supervised setting, it performs competitively. In summary, we introduce a new dataset, a lightweight joint HDR interpolation network, and a self-supervised training strategy, together forming an efficient real-time solution for HDR video synthesis. For more details and results, please visit our GitHub page. Thank you for your attention.